Okay, so number 7, so AD, it looks something like, probably not as, okay, something like that. Okay, if I was to rotate it 180 degrees, right, okay, that would be that line. This one would be up here, the long one would be up there, small one would be down there, and that would be like so. Okay, so A, D, E, B, C. So this would be, yeah, it would look something like that anyway, upside down, 180 degrees. Right, it's fine, don't worry about it. Right, what shape is made by the image and the original trapezium? Right, I think it makes a parallelogram. Do you all see that? The original one. Right, okay, if I try and draw it a bit more accurately. Right, okay, so there's the image. Right, this is the image. So the image and the original shape will make a parallelogram. Is that okay? Right, what is the area of this composite shape? Explain how this proves the formula for the area of a trapezium. Okay, this would be, so this would be AD. This is AD down here. So it would be the base by the perpendicular height. So it would be BC plus AD multiplied by the perpendicular height. Would you agree? That's for a parallelogram, base by height. Base by height. Would you agree with that? Okay, the original shape, so that would be the area of the final shape. Right? The original shape would be half that, wouldn't it? Would you agree? The original shape would be half that. And that's the formula for the area of a trapezium. Right? That's all. Is that right? It's the top line, the two parallel lines added together, divided by 2, multiplied by the perpendicular height. Are we good with that? Yeah, that was a bit of a nothing question, really. Right, 8. Am I doing 8? Yeah. Right, okay. 3 times the width of a certain rectangle exceeds twice its length by 3. Right, okay. So if you take twice its length and you take away 3 off it, you get 3 times its width. Right? And the other one is 4 times its length is 12 centimeters more than the perimeter. So 4 times its length, if you take away 12, you'll get the perimeter. So the perimeter is twice the length plus twice the width. Is that okay? Do you see where I came up with those? Right? So it's 3 times the width of a certain rectangle exceeds twice its length by 3. So that means it's bigger by 3. So if you would take away 3 of twice the length, you get 3 times the width. And the other one is 4 times the length, take away 12, 4 times the length is 12 more. So if you take off 12, it'll be the same as perimeter. The perimeter is twice the length plus twice the width. Yeah? Is that okay? Rearrange so I can do them simultaneously. The top one, 2L minus 3W equals 3. And the bottom one, bring over that L, it's 2L minus 2W equals 33. Have I rearranged that okay? I think it's okay.
Wait, miss, I think it's just 12 plus the 2L on the other side of that.
Oh yeah, I read that as a 21. Oopsie, thank you. Right, can't read my own writing, which isn't good. Right, okay, write simultaneous equations, change that to a minus, that becomes a plus, that becomes a minus. Right, they cancel, you'll get minus W is equal to, now I also have something wrong here, do I? No? Minus 9, so the width is 9, is that right? And then 2 times the length minus 3 times 9 equals 3, so that's 2L minus 27 equals 3, so that means 2L is 30, so that means L is equal to 15. So the width is 9 and the length is 15, and they're all in centimetres, so if they give us units, we must give them units back. Is that right? Sorry. Is that okay? Any questions? That's pure algebra as opposed to area and volume myself, I think, but anyway. The only thing you needed to know was the perimeter is twice the length and twice the width. Right, are we good? Right, okay, how am I going for time? Because as I say, I just corrected you, then I'll go on to something new. Right, no, I'm okay for a while. Can I move on? Right, number 9. Right, am I doing number 9? Am I doing 9? Yeah, okay. Peter has 3 rods, P, Q and R. Right, and I need by colours. Okay. P, Q and R. Do I have a red? I do. So P is red. Right, okay. Q is green. It's a bit shorter. Right, so this is P, Q and R is blue and it's shorter again. Right, okay. So P, Q and R. So they said he wants to make a trapezium shape with 2 right angles as shown. Okay, so we want 2 right angles as shown. Right, okay. So the one they show is the reds on top, the blues at the side, and the greens at the bottom. Where's the green? Right, okay, that's the one shown. Sorry, that should be. And if you connect them up, it's a trapezium, yeah? That's the one shown. And they say, draw the 3 possible arrangements, right, of the rods. Okay, so then we could have, we could swap the red and the blue here. So we'll still have the red on top, right? Okay, we'll have the green down the side, and we'll have the blue on the bottom. Okay. And the blue is the shortest one. Is that all right? There's a trapezium. Right, okay, let's rearrange again. Okay, so let's do the red down the side.
Yes.
Yeah?
Never actually asked you to draw things.
Yeah, they could, yeah. Why wouldn't they? Green on top, blue on the bottom. Okay, is that it? Is there another one? Right, because remember they can be flipped around. Okay, so you know, if I turn that upside down, it would be the same thing as the red on the bottom and the blue on the top and the green on the side. So I think you just have to change the side one, right? And it doesn't matter where you put the red and the blue. You know, once you make the side one, it doesn't matter where you put the others, because you can flip it upside down to make it the same anyway. Do you know what I mean? So I think they're the 3 arrangements. Is that all right? Okay. Yes. Yeah. Okay, so then it says, right, draw the possible arrangements of the rods, the inequality, find which arrangement has the greatest area. Right, okay. So the area here would be, if it was this one here, can I just do the area? So it would be the red plus the green over 2 multiplied by the height, which is R. Agreed? Right. This one would be the red, which is P, plus the blue, which is R, divided by 2, multiplied by the perpendicular height, which is Q. Agreed? Okay. And this one would be the green plus the blue divided by 2 multiplied by the perpendicular height, which is P. Okay, so I've just used the area of a trapezium formula, which is the length of one parallel line, add the length of the other parallel line, divided by 2 multiplied by the perpendicular height. And remember, the perpendicular height is the other side because they told me they were right angles. Are we good with that? So I need to compare the 3 of those, okay, and say which one is bigger. Okay, so if I say, I'm just going to write them out here. So P plus Q over 2 multiplied by r is 1. P plus r over 2 multiplied by q is another one. And the last one is q plus r over 2 multiplied by p. Are we good? Right, there are the three of them. I'm going to compare these, right? So I'm just trying to decide which one of these is the biggest. They're all divided by 2, would you agree? So I can just knock off that over 2, right? If I was trying to calculate the area, I couldn't, but I'm just comparing them. So I'm trying to make them as big as, or as kind of reasonable looking as possible. Going to multiply into this one. This one is PR plus QR, right? This one is PQ plus QR, and this one is PQ plus PR, right? Are we okay? Right, I'm going to compare these two, right? I'm just going to take them two at a time, and out of these two I'm going to decide which one is bigger and then compare it to the third one. Is that okay? Right, so I'm comparing these two, right? Observation. There's a QR in each one, isn't there? Right, so I can knock it off, okay? Because just for comparison purposes. So I'm actually comparing PR with PQ. Which one is bigger? PQ, because Q is longer than Q, isn't it? So this one is bigger. Would you agree? Okay. So now I'm going to go back, right? Okay. And I'm going to, so this one is gone. That's definitely not the biggest. With me? Right. I'm going to go back now, and this one is PQ plus QR. Right. I'm now comparing that with PQ plus PR. So I'm trying to figure out which one is bigger. Agreed? Right, okay, there's a PQ in each one, so that's not going to affect each one. So I'm actually comparing QR with PR, right? So, which is bigger? PR, isn't it? Because P is longer than Q, yeah? So this is bigger. So this is the biggest triangle, which is, or the biggest trapezium even, which is this one. Is that right? Are we good? Okay, so that's just kind of a process of elimination, really. There was nothing mathematical. There was no numbers to crunch. Right, okay. Number 10, am I doing 10? Using 10, number 10, you have to use a bit of trigonometry in it, okay? So we have this. Alright, this is 14 centimeters, this is 6 centimeters, this is 5 centimeters, and this is also 5 centimeters. Okay, right, what I need is the perpendicular height, okay, because I have to get the area of a trapezium. That's a trapezium, so it's A plus B over 2, which are the two parallel lines, A and B, right, over 2 multiplied by the perpendicular height. I'm looking for the perpendicular height. I don't have the perpendicular height. Is that okay? So I need to find it. So if I just draw in the perpendicular height here, right? I could also draw it over here, and they're the exact same triangles. How do I know they're the exact same triangles? Because these lines are both 5. Is that okay? So they're the exact same triangles at each side. Agreed? So if the whole lot is 14, in the middle is 6, so that leaves 8 centimeters between here and here. Would you agree? So it would have to be 4 centimeters and 4 centimeters. Agreed? Okay, let's just take one of those triangles. Okay, this is 5, this is 4, this is the perpendicular height. I just call it X there for a minute. I need to find the perpendicular height. Anyone make a suggestion? Pythagoras' theorem. So 5 squared is equal to 4 squared plus x squared. So that's 25 equals 16 plus x squared. So x squared is 9, so that means x is 3. Is that okay? So the perpendicular height is 3. And then to get the area of the triangle, it would be 6 plus 14 over 2 multiplied by 3, which is 30, and its area, and it's a cm squared. Is that okay? Are we good with that? Okay, time-wise, yeah, I'll just do one more and then I'll come back to it tomorrow. Right, okay, because I want to move on. Right, 11, am I doing 11?
Yeah.
Right, okay. The area of an equilateral triangle, so equilateral triangle, is 173 centimeters squared. Find the length of one of its sides. Right, okay, equilateral triangles, they're all equals. This is x, and this is x. Agreed? Right. When you drop a perpendicular, in order to get the area of a triangle, I need the base and the perpendicular height. Agreed? Okay. So I need the perpendicular height, so I'm going to draw it there in the middle. Because it's an equilateral triangle, girls, when you draw an equilateral triangle, it bisects, when you drop a perpendicular from the vertex down to the base on an equilateral triangle, it bisects the bottom. Okay? Right? It also does that in an isosceles triangle. The only triangle it wouldn't do that in is if it was a scalene triangle. Right, okay, I have a right angle here, right angle triangle, would you agree? Right angle triangle here, this one is x, and this is x over 2. Okay, I need this in terms of x, so I need to get this in terms of x. So, will I just call that y for the moment? Okay, agreed? Pythagoras' theorem. Hypotenuse squared, x squared equals x over 2 to be squared plus y to be squared. Agreed? Right, okay, so that would be x squared equals square the top, square the bottom, x squared over 4 plus y squared. Right, that means y squared equals, that's 1x squared, take away a quarter x squared, which would be 3x squared over 4. Yeah? So then the square root of all of that, get the square root of each component separately. Right? So that would be the square root of 3 on top. Square root of x squared is x, and square root of 4 on the bottom is that. So instead of y, I can write root 3 over 2. X. Is that okay? Everyone with me? Right, so then area of a triangle. So back up to the original triangle, I want the area of that. So it's a half multiplied by the base, which is x, multiplied by the perpendicular height, which is root 3 over 2 times x. And I know the answer, it's 173. Is that okay? No, over here?
Yeah.
No, it's root 3. I've got the square root of x squared, which is just x. So the only thing that's under square root sign is the 3. Okay, we good? Right, okay, so that would be multiply out here. So on top I have root 3x squared, and on the bottom I'll have all that's over 4. With me? So that equals to 173, is this, cross multiply and divide. I think it might end up as a decimal, does it? Does it? Yeah, if you cross multiply you'll get root 3x squared equals 4 3s are 12, 4 7s 28, 1 is 29, 4 1s are 4, and 6 9 2, I think. Right? Then divide each side by root 3, and you get x squared is equal to whatever that is, and then get the square root of that. Is that right? I think it might turn out to be a decimal, does it? People, anyone have an answer? X equals 9 point.
It's like 19.999.
19.999. right, we'll round it up to 20, so, or will we? I don't know. They don't actually say, they normally say. Right, okay? Is that all right? Questions? Problems? Right, okay. 12 and 13 was what you had also, was it? Okay, yeah. What I might do is, right, I might come back to them tomorrow if that's okay, because I need to move on, okay? So I just have to, the next section is circles, so I just have to talk about, again, it's all revision in the next section, right, but the questions are harder as before, okay? So I don't think there isn't any new information here, okay? So just writing down everything we need to know about circles, right? Circles, the circumference of a circle, sometimes called the length of a circle. I think in the log tables they call it the length, right? And they'll tell you length is equal to 2 pi r. So 2 pi r means 2 multiplied by the number pi, which there's a button on your calculator, so we don't use 3.14 anymore. We use the button on our calculator, right? And r is the radius of the circle. Okay, the area of a circle, area is equal to pi r squared. You know all this, don't you? This is just revision, right? Okay, right, angle in a semicircle is a right angle. Angle in a semicircle is a right angle. Right, okay, so if we have a circle and we have a semicircle, as in, that was really bad, right, okay, we have a semicircle, right, where there's a diameter. If you draw any angle at the circle, so if it goes up, hits the circle, and goes back to the other end of the diameter, that's a right angle, okay. I'm going to draw a few of these, you only need to draw the one, okay, but just so you get, right. So if I have a diameter, if I start the angle at one end, go to the circle, has to hit the circle, goes back to the end, right, that's a right angle, okay, right. So another example, right, if I draw a semicircle, right, if I go to the circle, right, hit the circle, and go back to the end, right, no matter where the angle is, it's a right angle. Just be careful, girls, right, okay, so it has to go to the circle, as in that is not a right angle because it's not at the circle. Does that make sense to people? So the angle in a semicircle is right angle. You learned that in junior search, you might remember, but you did. Right, and the last thing I want to tell you is cyclic quadrilaterals, so opposite angles in a cyclic quadrilateral add to 180 degrees. Opposite angles in a cyclic this was also on your junior cert course, okay. Opposite angles in a cyclic quadrilateral add to 180 degrees. So what's quadrilateral? Any four-sided shape. Cyclic quadrilateral is it's in a circle. So you have a circle and then you have a four-sided shape. So each corner of the shape is on the circle. So that's a cyclic quadrilateral. Okay, it's four-sided shape inscribed in a circle, right? The opposite angles add to 180 degrees. So if it's a cyclic quadrilateral, right, the opposite angles add to 180 degrees. So A and C add to 180, and B and D add to 180. Is that okay? So A and C add to 180, B and D add to 180. Are we good with that? That was a fact you learned in junior cert also. Okay?
Miss, how do you spell what is it?
Cyclic, C-Y-C-L-I-C. Cyclic, it just means it's in a circle. Right, okay. And the last thing I want to talk about today is sectors of a circle. So a sector of a circle is like a pizza slice, right, okay? So, can I move up? Can I move up? Going, gone? Right, okay, so sector of a circle. So a sector of a circle is a pizza slice, okay? So if we had something like this, that's the sector of a circle, right? Okay, so what they have to tell you, girls, is, remember it was a full circle, but now they've reduced it down to a sector. Okay, you need this angle in here, so they have to tell you this angle in here. So this angle will go into, it's just a Greek letter, it's like ABC, it's called theta, right? It's just a Greek letter. It's the one they use in the log tables, that's why I'm using it. Okay, so it's just a Greek letter, it's like ABC, you call it theta. Okay, so if you want to get, and remember the radius of a sector is here. If you want to get the area of that sector, it's theta out of 360. So you have to work out what fraction of the circle you have. So you do that using the angle. So it's whatever fraction of 360, right, multiplied by pi r squared. So pi r squared is the area of the full circle, so whatever fraction you have of the full circle. And the length is theta over 360 multiplied by 2 pi r. Okay, so again, that's it. There's nothing new. Every single bit of that was on your junior cert course. Okay, I've no time for examples because I'm going to run out of time. Okay, so what I'm going to do is I'm going to give you a few of these to do for homework, and we'll iron out the problems tomorrow. I'll do the corrections tomorrow as examples. Okay, so we'll do page 170 to 171. Let's do one to 8. And you want the pictures up, yeah?